Now, the next three talks are actually from Luxembourg students at the University of Luxembourg. And first up, we have Natalia Stepanova. So, Natalia, are you with us?
Yes, hello.
Hello, we can see you. Yes, we can. The floor is yours.
Okay. Good afternoon. First of all, I would like to thank the organizers for the opportunity to be part of such a large-scale and unique event. And now I would like to share some information about the Herschel resupply mission feasibility study we were doing with my colleagues under the guidance of Dr. Paspogel and Dr. Menso. Next slide, please. Thank you. The possibility of the use of space resources, including those of the moon, has recently been the subject of increased public attention as a key for future space missions. In this regard, we were working on the evaluation of the ISRU benefits for the Herschel Space Observatory mission. Now a few words about Herschel. It operated in the far infrared to sub-millimeter spectrum at the distance of 800 kilometers from Earth. From L2, sorry. The main mission objectives are discovering how the first galaxies formed and evolved, also studying chemical composition of the planet. In the universe, many objects have temperatures close to absolute zero, and colder instruments are required to observe them. And therefore, the key element here is cooling. Herschel DVAR contains 300 kilograms of superfluid helium, which determines the lifespan of the mission. And in that sense, the helium cryostat is considered as a critical subsystem for the ISRU, and less critical subsystems are propulsion, EPS, and others. The minimum Herschel modification possible was given as a constraint for this task. Next slide, please. The resupply mission scenario starts with launching Herschel to space from the Earth. Considering the future interest of helium-3 for fusion, we are assuming that lunar regolith mining will take place to harvest a clean and efficient form of energy. And by doing so, helium-4 would be available as a side product in abundance. And we were considering using it as a coolant, which could be obtained basically for free. Also, at this point, the human outposts on the moon, lunar gateway, and mining infrastructure were assumed to be completely functional. In order to perform refilling itself, we are considering to borrow a cargo satellite from the lunar gateway. And the cargo lands on the moon, mounts a payload module for refilling, and takes off to rendezvous with the Herschel at L2. Then resupply spacecraft autonomously docks to Herschel, ensuring stable connection, and transfers the lunar helium to Herschel's DVAR. Once the refilling is complete, Herschel returns safely to its scientific mission, and the resupply spacecraft to its operations for the lunar gateway. Next slide. Two use cases scenarios for ISRU on Herschel were determined. Extending its lifetime and improving its performance. During phase one, we were studied the refilling of Herschel and considered it is worth only 4 times increase on Herschel's lifetime, which is growing from 3.5 years to 14. For the stated period, the helium consumption requires 3 refillings, and 100% filled tank with fuel would be more than enough. As for solar array degradation for 14 years, it is equal to 66%. And for this, Herschel solar array area should be increased. Concerning the improvement of Herschel performance, 3 options are under evaluation. The first is running 2 instruments at the same time. Second is to allow higher instrument dissipation to get more performant instruments and extra instruments on board. The evaluation, the economic cost evaluation and the dissipation evaluation are supposed to be done in the second phase. Next, please. The overall benefits could be distinguished as from ISRU for Herschel and from moon mining. From ISRU for Herschel, as extending lifetime and performance will increase the scientific return. and the overall cost of the extended mission will be significantly lower than multiple Herschel missions. From the moon mining, we have helium-3 mining return, and also water and oxygen supply independent from the Earth for the lunar outpost. Next, please. As the conclusion, the first phase has been completed and helium-4 refilling on orbit has been found feasible to extend Herschel lifetime. The required moon mining costs and benefits will be evaluated in the second phase of the ISRU research project. And as part of the second phase, we are currently working on the master thesis topic, which is called as Understanding and Maximizing the Benefits of ISRU for Herschel Space Observatory, a system engineering approach. That's all from my side. If you have any questions, please, I am ready to answer. The next slide, please, with contact also for the further questions.
Thank you, Natalia. We can't see that final slide with your contact details, but I'm sure people can find you at the University of Luxembourg, Natalia Stepanova. At the moment, I couldn't see any questions on the chat for you, but I'm sure you're there online as well and will follow the next couple of days.